Hello students, I'll tell you how to check whether the given equilibrium point is a stable point or not. An equilibrium point is a point at which the motor torque and the load torque are equal. Now consider the characteristics of the load torque and the motor torque. The point A is an equilibrium point at which the motor torque and the load torque both are equal. Now let me check whether the point A is an stable point or not. For checking that, let us introduce some disturbance in the system. Due to that disturbance, the point A is now shifted to the point A1. At the point A1, the corresponding speed is omega A1 and the corresponding load torque is TLA1. And for that same point, the corresponding motor torque is TA1. If you check the values of the torque, the TA1 value is less than TLA1, which means the motor torque at the point A1 is less than the load torque TLA1. Due to that, deceleration takes place, which makes the speed of the system to decrease. And so the point A1 is brought back to the point A, which means even after the disturbance taking place in the system, the point which is shifted to the point A, which is shifted to the point A1, is brought back to the original point A, which means the given equilibrium point is stable equilibrium point. Now let us consider the other case wherein some disturbances causes a decrease in the speed, and so the point A is shifted to the point A2. At the point A2, the speed of the system is omega A2 and the torque of the load is TLA3. And for the same speed, if you check the motor torque, it is equal to TA2. And if you check the value of TA2, which is greater than the value of TLA2, which means the motor torque is greater than the load torque, which causes the acceleration of the system. So the speed increases and the point is brought back to the point A, which means the point A is a stable equilibrium point. So for an equilibrium point to be stable, the condition required is when there occurs an increase in the speed, the motor torque should be greater than the load torque, and when there occurs a decrease in the speed, the motor torque should be greater than the load torque. This is the condition for stable equilibrium point. Let us take another example in which this is the load torque characteristic and this is the motor torque characteristic, and the point B is the equilibrium point where the load torque and the motor torque are equal. Now due to some disturbance, the point B is shifted to the point B1, at which the speed is omega B1 and the torque is TLB1. Torque of the load is TLB1. And for the same operating point, if you check for the motor torque, it is equal to TB1, and you can see that TB1 is greater than the torque TLB1. The motor torque TB1 is greater than the load torque TLB1, which causes acceleration. So the speed further increases and the point B1 moves towards upper side, and we can see that it is not brought back to the point B. And due to some disturbance, if you consider that the speed of the load is decreased to a speed omega B2, so that the point B is shifted to the point B2. At the same time, at the same operating point, if you consider the load torque value, it is TB2, which is TB2 is less than the load torque TLB2, which causes deceleration of the system. So the speed is decreased further and the point B2 is moved towards the down part of the load torque characteristics. So the point B2, it is not reaching its original position B. Hence the point B which is the equilibrium point, which is not a stable equilibrium point. So point B is not stable equilibrium point.